We're now going to talk about terminal operators in the observable class. And as with the other discussions, there are going to be other terminal operators we're going to cover later. Right now, we're going to talk about the blocking subscribe terminal operator, which terminates an observable stream and triggers all the processing of operators in the stream and blocks for the results to complete. We'll talk later in another lesson about non-blocking subscribers, which are actually more common in practice, honestly, than blocking subscribe. But blocking subscribe has some nice properties we're going to talk about. So the blocking subscribe operator subscribes a couple of consumers and a runnable to the current observable. And these parameters, consumer, error consumer, and complete consumer, consume all the elements in the sequence. That's what consumer does. Handles errors. That's what error consumer does. And or reacts to completion. And each of these things might be useful, although error consumer and complete consumer are mutually exclusive because you cannot have them both occur. You can only have one occur. And they may neither of them may occur. Actually, none of these things may occur, but we'll talk about that in a second. Blocking subscribe on observer gives a request to the publisher that says, I have unbounded demand. You can send me an infinite number of things, and I'll be able to handle it. And you can send them as fast as you want, and I'll be able to handle it, I think. Now, if it can't, there's other issues, but it has unbounded demand. We'll see when we talk about other subscribers and other mechanisms like Flowable that they give you this ability to have bounded demand. Signals that are emitted to this operator, to blocking subscribe, can be represented by the following regular expression. We've talked about this earlier when we talked about the reactive programming model at large with the way in which the flow interface, the flow classes in Java work. And basically, you can have 0 or more calls to onNext, followed by, optionally, 1 onComplete or 1 onError call. The other thing that blocking subscribe does, much like collect or reduce in Java streams, is it triggers all the processing in an observable chain. So when blocking subscribe is invoked, then everything starts to run. And up to that point, nothing runs because these are lazy. The whole thing is lazy until blocking subscribe or subscribe, some variant of subscribe is called. There are, again, 3 different types of parameters you can pass here. The first 2 are consumers. The last is a runnable. The first one handles normal processing. So, for example, in this case, we're going to create 4 big fractions, multiply them by some constant, and then if it all works, we're going to go ahead and append them as a mixed string to this string builder or string buffer. If something goes wrong, we're going to append the word error to that string builder or string buffer. And when we're done, then we go ahead and we display the results. Now, this particular example, because of the constraints of the slide, we also would actually want to display the results on the error case as well. But to keep things from running off the end, I didn't show that here. But this completes the processing and displays the results. Unlike most operators in Observable, the blocking subscribe operator will block the caller thread until the upstream terminates normally or with an error. In other words, when other things earlier in the stream are done. So the thread will not continue. And that's actually very useful for testing purposes if you don't have something as cool as the async task barrier we talked about before. For some odd reason, there's no equivalent in Project Reactor. There's no blocking subscribe operator at all. And so you have to kind of do a bunch of other fancy, funky things. It complicates testing a bit unless you use the async task barrier or if you use something called a step verifier, which is a cool way of validating that your reactive streams work correctly. And Project Reactor has one, and RxJava has something very similar. So that's the end of the discussion of the blocking subscribe terminal operator. As I mentioned before, most of the operators in RxJava don't block. There's a handful that do, but most don't. Blocking subscribe is sort of the exception that proves the rule. There's also a whole family of non-blocking or asynchronous subscribe operators, which are much more common, and we will cover those when we get to a case study that's a little bit further along.